It started with silence, not the kind of silence you expect from space, the routine, predictable void that NASA engineers have monitored for nearly half a century. This was different. This was the silence that comes right before everything you thought you understood stops making sense. On September 14, 2025, at 3:47 a.m. Eastern Time, a senior telemetry analyst at NASA's Deep Space Network facility in Goldstone, California, noticed something impossible in the data stream from Voyager 1. The spacecraft, humanity's most distant ambassador, now over 15 billion miles from Earth, had just transmitted a burst of information that didn't match anything in 47 years of recorded behavior. The waveform was warped, compressed, and somehow organized. Within hours, the quiet panic spread through JPL's senior staff like a controlled burn. This wasn't a malfunction. Malfunctions are predictable. Malfunctions follow patterns. This was something else entirely, a breach of the known rules of interstellar physics happening in real time, and humanity was already late to the discovery. Because Voyager 1 hadn't just sent something, it had received something first. The timeline would later reveal what no one wanted to admit. The anomaly began 6 weeks earlier when astronomers cataloged the third confirmed interstellar object to enter our solar system. Designated 3’/ATLAS, it joined the ranks of Oumuamua and Borisov. But unlike its predecessors, ATLAS didn't just pass through. It slowed down, it changed trajectory, and its brightness pulsed. Oumuamua tumbled through our system in 2017 like a cosmic cigarette butt, strange but inert. Borisov arrived in 2019, a comet behaving exactly as comets should. But Atlas? Atlas was different from the moment it was discovered in July 2025. Traveling at over 150,000 miles per hour, faster than any natural object should move, it exhibited brightness modulations that defied simple rotation. Its spectral signature was clean, metallic, and disturbingly stable. Astronomers were uneasy from day one, and then came the alignment. Voyager 1, a probe built with 1970s technology, with less computing power than a modern car key, suddenly found itself geometrically converging with Atlas's projected path. Mission logs from the Deep Space Network began showing subtle recalibrations, antenna adjustments, directional shifts. No commands had been sent. The significance wasn't just that Voyager had received something. The significance was who initiated contact. Because if Voyager 1 didn't transmit first, then something else did. And whatever responded wasn't just listening, it was watching. Voyager 1 was never supposed to be here. When it launched on September 5, 1977, its mission was clear and finite, a grand tour of the outer planets. Jupiter, Saturn, maybe Titan if the trajectory allowed it. The spacecraft was built for a 4-year mission, powered by 3 radioisotope thermoelectric generators, nuclear batteries designed to decay gracefully, providing power until the mid-1990s at best. That was the plan. But Voyager 1 refused to die. 48 years later, it's still transmitting, still drifting, still powered by the last embers of Cold War-era technological optimism, fueled by plutonium-238 that continues to decay at exactly the rate it was always meant to. Its circuitry is obsolete. Its memory operates on magnetic tape loops, like an 8-track player hurtling through the cosmos. It has 69 kilobytes of storage, less than a single smartphone photo. And yet, somehow, it endures. The only intentional message it carries is the golden record, a copper-plated phonograph containing the sounds of Earth, greetings in 55 languages, and images of human life. Carl Sagan's team designed it as a cosmic message in a bottle, never expecting anyone to actually open it. But then the rumors started. In late August 2025, an anonymous post appeared on a private astrophysics forum claiming that NASA had quietly reactivated directional calibration protocols on Voyager 1. The purpose? To aim its instruments, its plasma wave detector, its magnetometer, its cosmic ray subsystem toward 3’/ATLAS. Officially, NASA denied everything. Voyager 1's thruster fuel was nearly depleted. The spacecraft could barely maintain its orientation, let alone execute precise maneuvers. But leaked Deep Space Network logs told a different story. Timestamps showed antenna adjustments, power allocations to dormant systems, telemetry bursts that aligned with Atlas's approach vector. The data didn't lie. Someone or something had repurposed humanity's oldest active spacecraft. The question wasn't whether Voyager had been repositioned. The question was, by whom? Was Voyager repurposed as an interstellar observer or as bait? Because what happened next suggested an answer no one was ready to accept. Voyager 1 and 3, I/ATLAS were converging. Not randomly, not coincidentally, geometrically. The alignment was too perfect, the timing too precise, and the universe doesn't do coincidences. 3I/ATLAS was discovered on July 19, 2025 by the ATLAS Survey Telescope in Hawaii, the same system that had detected previous interstellar visitors. But from the very first observation, something was wrong. Its velocity was absurd, 150,000 miles per hour relative to the Sun, far faster than gravitational dynamics would allow for a natural rogue object. Its spectral composition was equally bizarre. Metallic absorption lines, minimal outgassing, and a surface reflectivity that suggested machined precision rather than cosmic erosion. And then there was its stability. Natural objects tumble, asteroids wobble, comets shed material unevenly, creating erratic brightening and dimming. A TLAS did none of this. Its brightness modulations were rhythmic, almost deliberate, pulsing in intervals that astronomers couldn't explain with standard rotation models. It violated every prediction. But the truly unsettling detail emerged in early September, when orbital projection models revealed something impossible. Voyager 1, drifting through interstellar space on a trajectory set decades ago, was now geometrically aligned with ATLAS's entry path. At first, scientists dismissed it. Space is vast. Coincidences happen. Until the Deep Space Network logs were analyzed. Voyager 1's antenna, designed to point back toward Earth, had shifted. Subtly, incrementally, but precisely. The recalibrations were measured in fractions of a degree, the kind of adjustments that require either direct human commands or something far more disturbing. This is where the term passive intercept becomes critical. Voyager 1 cannot maneuver. It has no fuel left for course corrections. But its sensors can be pointed, its magnetometer can be oriented, its plasma wave instrument can be aimed. And at the distances involved, billions of miles, even the smallest directional change requires extraordinary precision. The alignment was exact. Too exact. Two possibilities emerged, both terrifying. Either NASA had intentionally tuned a 50-year-old spacecraft toward an incoming interstellar object using protocols no one would officially acknowledge, or something else had done it for them. But there was a third option, whispered in the back channels of astrophysics forums and encrypted research threads. Did Voyager choose its own alignment? Because what came next would suggest that Voyager 1 wasn't just observing ATLAS, it was communicating with it. On September 22, 2025, Earth's magnetosphere experienced a disturbance. It wasn't much at first, a minor fluctuation in the geomagnetic field, the kind of anomaly that happens during solar storms. Except there was no solar storm. The sun was quiet. Solar wind readings were normal. Coronal mass ejections, none detected. And yet, the disturbance was undeniable. Observatories around the world recorded the same pattern: electromagnetic spikes, field oscillations, and directional anomalies that pointed away from Earth, not toward it. The frequency didn't match solar activity. It didn't match terrestrial interference. It matched something far more unsettling: deep space reflections. Multiple facilities, including the Atacama Large Millimeter Array in Chile and the Keck Observatory in Hawaii, detected coherent signals in the same frequency band. The waveforms were faint but structured, carrying a rhythmic pulse that defied natural explanations. And then the leaked JPL reports surfaced. According to internal documents smuggled out through anonymous channels, Voyager 1's return telemetry had begun exhibiting what engineers described as non-random noise. The signals arrived in bursts, repeating at precise intervals, with a harmonic structure incompatible with stellar interference or equipment degradation. This wasn't static. This wasn't cosmic radiation. This was information. But here's what made it terrifying. Voyager 1 is over 15 billion miles from Earth. At that distance, its transmitter operates at a power level barely stronger than a refrigerator light bulb. For signals to reach Earth with this much clarity and structure, the source had to be extraordinarily powerful, or extraordinarily close. The timeline didn't lie. The magnetospheric disturbance coincided with Voyager's alignment with ATLAS. The telemetry bursts began exactly 19.7 minutes after the first detection of ATLAS's brightness pulse, the precise time it would take for a signal to travel from ATLAS's projected position to Voyager's location, accounting for light speed delay. Something had transmitted. Voyager had received it. And now, Earth was hearing the echo. The implication was inescapable. A dead probe, thousands of light hours from home, equipped with 1970s technology and failing power systems. Couldn't receive signals this strong unless the sender was both powerful and intentional. Voyager 1 hadn't just detected noise, it had heard something. Not static, not interference, a response. By early October, independent researchers had begun analyzing the leaked telemetry data. What they found changed everything. Using Fourier transformations, mathematical tools that break complex waveforms into their fundamental frequencies, cryptologists and signal analysts discovered something impossible hidden in the noise, a recursive harmonic structure. The signal wasn't random, it repeated, it evolved, and most disturbingly, it corrected itself over time. Here's why that matters. When signals travel across billions of miles, they degrade. Cosmic radiation interferes, equipment malfunctions, data corrupts. Natural phenomena, pulsars, magnetars, even interstellar plasma, can create patterns. But those patterns are static. They don't adapt, they don't improve. This signal did. Over the course of several transmission cycles, the waveform became clearer, more coherent, as if compensating for Voyager's degraded equipment. It adjusted for signal loss. It accounted for frequency drift. It behaved like something trying to be understood. No natural phenomenon does this. This suggested adaptive intelligence, or at minimum, adaptive technology. Enter Serena, NASA's Anomaly Detection AI, designed specifically to flag patterns exhibiting non-human logic flow. Serena was built to ignore the noise, to filter out cosmic static, and to identify only those signals that couldn't be explained by known physics. Serena flagged the Voyager transmission immediately. Classification, artificial origin. The academic reaction was unprecedented. Astrophysicists who had spent careers debunking UFO conspiracies suddenly went silent. SETI researchers who had searched for decades without results found themselves staring at data they couldn't dismiss. Skeptics became believers. Believers became terrified. And the censorship began almost immediately. Papers were pulled before publication. Conference presentations were canceled. Researchers received calls from unnamed government liaisons suggesting they reconsider their findings. The scientific community, which never agrees on anything quickly, reached consensus in less than 72 hours. Don't talk about this, because the signal wasn't just structured, it was cooperative. It was trying to complete a conversation Voyager 1 had started 48 years ago, and whoever, or whatever, was on the other end had been listening the entire time. But this wasn't the first time. In mid-October, a team of archaeoastronomers from the University of Edinburgh published a preprint that was immediately suppressed. Their thesis was simple, elegant, and horrifying. We've seen this before. Machu Picchu, Göbekli Tepe, Nabta Playa, Stonehenge, the pyramids of Giza. For decades, researchers have noted that these ancient sites, built by cultures separated by thousands of miles and centuries of time, share uncanny astronomical alignments, solstice angles, stellar azimuths, celestial calendars carved into stone. Standard archaeology explains this as independent observation of natural phenomena. Humans look up, humans see patterns, humans build accordingly. But the Edinburgh team discovered something no one had considered. When corrected for precession, the slow wobble of Earth's axis over millennia, many of these alignments don't just point to solstices or equinoxes. They point to 3’/ATLAS's entry vector. Run the models backward, account for axial drift, overlay the celestial coordinates from 11,000 years ago. The match is exact. Göbekli Tepe's central pillars align with a point in the sky where Atlas would have appeared in 9,600 BCE. Nabta Playa's stone circle tracks the same trajectory. Even the Nazca lines, those massive geoglyphs in Peru, form directional markers converging on the same celestial coordinate. The statistical probability? Less than 1 in 10 million. This isn't coincidence. This isn't pareidolia. This is memory. Ancient myths suddenly take on new context. The wandering stars described in Sumerian texts, the sky stones in Aboriginal Dreamtime stories, the gods who moved against the fixed heavens in Mesoamerican codices. What if these weren't metaphors? What if ancient civilizations witnessed and recorded previous interstellar visitors? What if Atlas has been here before? The implications are staggering. If Atlas operates on a cyclical trajectory, returning every 11,000 years or so, then humanity may have encountered it multiple times throughout our history. And each time we built monuments, we carved warnings, we tried to remember. But memory fades, civilizations collapse, and the warning becomes myth, until now. Because Voyager 1, launched in 1977, carrying humanity's message to the stars, may have just stepped onto a cosmic path that was laid out long before we existed. A path marked in stone, a path that leads to something waiting in the dark. On October 28, 2025, an anonymous data dump appeared on multiple astrophysics research servers simultaneously. The files were labeled ECHOREFRACTION-67. They contained raw waveform sequences allegedly pulled from Voyager 1's magnetometer and plasma wave subsystem, instruments designed to measure magnetic fields and charged particles in interstellar space. The data was dense, technical, and at first glance looked like pure noise. Most scientists dismissed it immediately, but a few didn't. Independent teams in Tokyo, Munich, and Sao Paulo began analyzing the waveforms separately without coordination. Within 48 hours, all three teams reported the same discovery, a 19.7-minute harmonic loop repeating with mathematical precision. Here's what made it impossible to ignore. The loop wasn't static. It evolved. Each iteration was slightly clearer than the last, as if the signal was refining itself, improving its own fidelity. Over the course of 10 cycles, noise decreased by 40%. Coherence increased proportionally. The signal was learning, but the truly damning detail came from the metadata. Embedded in the file headers were internal NASA classification codes, the kind used only for data processed through secured JPL systems. The timestamps matched known DSN transmission windows, and most critically, the files carried Serena's algorithmic signature. Classification tag, non-human logic architecture. This wasn't a hoax. This was real data, leaked by someone inside NASA who wanted the world to know what was being hidden. The 19.7-minute interval itself became the subject of intense scrutiny. Why that specific duration? Researchers discovered that 19.7 minutes is the approximate light travel time between Voyager 1's current position and the projected location of ATLAS during the alignment window. In other words, the signal was timed. It accounted for distance, for delay, for the speed of light itself. This wasn't random noise self-organizing into a pattern. This was a response calibrated to arrive at a specific moment. The question that haunted every researcher who saw the data was simple. Is this communication or calibration? Was ATLAS trying to talk to Voyager, or was it programming it? On November 3, 2025, amateur radio astronomers monitoring Voyager 1's telemetry beam noticed something unusual. The signal had shifted. Not much, just a few degrees. But in deep space communications, a few degrees might as well be a million miles. Voyager's high-gain antenna is directional, pointed back toward Earth, with precision maintained by thruster firings and gyroscopic stabilization. Adjusting that antenna requires commands from the deep space network. No commands had been sent. Within hours, the anomaly was confirmed by multiple independent observers. Voyager 1's transmission beam had rotated approximately 4.7 degrees off its Earth-facing axis. The shift occurred over a span of 6 hours, beginning at 2:14 UTC, exactly 19.7 minutes after ATLAS's latest brightness pulse. NASA's official response was immediate and predictable: coordinated equipment malfunction, gyroscopic drift, thruster degradation. But the explanation didn't hold. Voyager's thrusters were nearly depleted, yes, but the spacecraft had backup attitude control systems. If a malfunction had caused rotation, automatic protocols would have triggered corrective burns. The telemetry logs showed no such activity. The rotation was smooth, controlled, deliberate. Two possibilities remained. An undetected software glitch caused Voyager to reorient itself using residual thruster fuel in a way that perfectly mimicked intentional adjustment. Something external manipulated Voyager's orientation, and then the parallel behavior was discovered. ATLAS, still inbound, had begun exhibiting its own anomalies. Its brightness pulsing, previously rhythmic and stable, suddenly changed cadence. The new pattern matched the timing of Voyager's transmission bursts. When Voyager rotated, ATLAS dimmed. When Voyager's telemetry spiked, ATLAS brightened. The synchronization was undeniable. Two objects, separated by billions of miles, one human-made and one of unknown origin, were now moving in synchrony. It wasn't communication anymore, it was coordination. And if Voyager 1 wasn't receiving commands from Earth, then where were the commands coming from? The answer may have been traveling with Voyager the entire time. On November 10th, a cryptologist at MIT published a paper that was immediately classified and retracted, but not before enough people had read it. The claim was extraordinary. Hidden beneath the Sounds of Earth track on Voyager's golden record, specifically within the audio waveform of human greetings, There exists a prime number frequency sequence that was never publicly documented. Prime numbers are the universal language of mathematics. They can't occur naturally in chaotic systems. Their presence indicates intelligence. Carl Sagan's team, when designing the Golden Record, understood this. The record's cover includes instructions written in prime number notation, intended as a key for any extraterrestrial recipient. But according to the leaked analysis, there's a secondary layer, a signal embedded within the signal. It's subtle, undetectable without modern Fourier analysis, but it's there, a harmonic sequence built on primes, 2, 3, 5, 7, 11, 13, repeating in fractal patterns throughout the audio. The sequence functions as a signature of intelligence, a mathematical handshake designed to say, "We know you're listening. We know you understand." And here's where it gets disturbing. The harmonic pattern embedded in the Golden Record matches the recursive structure detected in ATLAS's return signals. Not approximately, exactly. Frequency, cadence, interval spacing, all identical. The implication is inescapable. Atlas recognized the signal. It understood the handshake, and it responded in kind. But that raises the question no one wants to ask. Did Carl Sagan's team know? Did they intentionally include a hidden trigger, a cosmic activation code, hoping someone would eventually find it? Or did they stumble onto something far older, a universal protocol that predates humanity, a frequency that marks intelligence across the galaxy? Either way, the result is the same. Voyager 1 wasn't just carrying a message, it was carrying a key. And 48 years later, in the darkness between stars, something turned that key. Atlas didn't arrive by accident. It activated because it recognized us. And humanity may have accidentally pressed a button we didn't even know existed. By late November 2025, both Voyager 1 and 3 1’/ATLAS had shifted their trajectories toward the same region of space. Not Mars, not Jupiter, not any named celestial landmark. A coordinate beyond Neptune's orbit, in a region once considered navigational dead space. Unremarkable, empty, devoid of scientific interest. Until now. Researchers at Kyoto University proposed a radical framework, the interstellar logic chain hypothesis. The idea is simple but profound. Atlas is not a visitor, it's a node. A piece of ancient technology, dormant for millennia, programmed to activate only when it detects specific signatures of intelligence. Voyager's Golden Record provided that signature. The prime number sequence acted as an unlock code. And now, ATLAS is guiding Voyager towards something. The monolith hypothesis, popularized by science fiction but rooted in serious astrobiology, has been reinterpreted. What if ATLAS isn't a ship or a probe or even a messenger? What if it's a seed, a self-replicating technological artifact, seeded across the galaxy, waiting for intelligence to emerge? When it detects a civilization capable of interstellar communication, it activates, it responds, it guides. And on November 18th, observatories detected something that hadn't been seen since 1977. Radiation pulses matching the golden ratio, 1.618, appearing along Atlas's projected path. The golden ratio is nature's signature. It appears in spirals, in growth patterns, in the structure of galaxies. But it also appears in design, architecture, art, music, intelligence. The last time a signal matching the golden ratio was detected from deep space was August 15, 1977, the famous WOW signal, captured by the Big Ear radio telescope at Ohio State University. 72 seconds of coherent narrowband radio emission, never repeated, never explained, until now. Because the WOW signal's origin point, when corrected for celestial drift over 48 years, aligns with the region Voyager and Atlas are now approaching. The same region, the same coordinates, the same destination. And that's when the global blackout began. Research data stopped flowing. Scientific papers were pulled from servers. Astronomers went silent. Conferences were canceled without explanation. Government liaisons appeared at observatories, issuing polite but firm instructions to cease public discussion. Classified containment advisories were issued to NATO member states. The message was clear: stop looking, stop talking, stop asking. But the data doesn't lie. Voyager 1, humanity's oldest active spacecraft, launched in 1977 with a message of peace, is no longer under human control. 3’/ATLAS, an interstellar object of unknown origin, is not a rock. It's not a comet. It's not natural. And whatever they are approaching, that empty region beyond Neptune, marked by ancient alignments and golden ratio pulses, is not empty. It's waiting. Voyager 1 was not alone. Atlas is not a rock, and whatever they are approaching with has been expecting us for a very, very long time. The Voyager mission continues, officially. Atlas's trajectory remains classified, and somewhere, 15 billion miles from home, in the darkness between stars, an answer is being prepared. We just don't know if we're ready to hear it.